November 16, 2025. Astrophotographer Satoru Murata releases a composite image of interstellar object 3I Atlas, 24 exposures, 60 seconds each, captured through a 0.2-meter telescope in New Mexico. The image reveals multiple jets extending in different directions relative to the Sun, including an anti-tail and a remarkably long, tightly collimated plume. The jets appear laser straight across distances that should make that impossible. You're about to discover why. 7 independent observatories just confirmed a measurement that contradicts what those images show, and why Harvard astrophysicist Avi Loeb has proposed 4 explanations, 3 of which have already failed. If an object completes 45 rotations while gas travels outward for a month, why do the jets maintain a single frozen direction? One day after Murata's image, Francois Kugel posted follow-up observations. 22 exposures of 30 seconds each using a 0.4-meter aperture. Same phenomenon. Jets that defy the behavior expected from rotating bodies.
The last time we checked, it has a rotation period of only 16 hours, and the length of these jets is 1 million kilometers. You would expect that the material making up these jets had to go across that distance over a period of a month.
This isn't an imaging artifact or perspective illusion. It's reproducible across instruments, observers, and nights. Which brings us to the confirmation of 3I Atlas's 12th anomaly, potentially the most paradoxical yet, because it directly challenges rotational physics that have worked flawlessly for a century. But before examining what makes this 12th anomaly so troubling, you need context. In 20 seconds, you'll see why this is anomaly number 12 in a list that defies statistical probability. 3I Atlas arrived on a retrograde trajectory, aligned within 5 degrees of the ecliptic plane, likelihood 0.2%, like threading a needle in 3-dimensional space. During July, August, and early November 2025, it displayed a sunward jet that wasn't a geometric perspective trick, but actual material firing toward the star, violating radiation pressure. Its nucleus outweighs Oumuamua by 1,000,000 times, and Borisov by 1,000. Yet moves faster than both, probability below 0.1%. Arrival timing positioned it perfectly for close passes of Mars, Venus, and Jupiter, while remaining unobservable from Earth at perihelion, odds of 0.005%. Spectroscopy revealed far more nickel than iron, resembling industrial alloys rather than cosmic randomness.
This is a very old object, perhaps 7 billion years old. And in 7 billion years, there's been plenty of time to accumulate garbage. That's why, for example, the nickel content of the comet is off scale.
With nickel to cyanide ratios orders of magnitude beyond any known comet, including Borisov, likelihood under 1%. Its gas plume contains only 4% water by mass, when comets typically run 80 to 90%. It shows extreme negative polarization, unprecedented in the entire comet catalog, including interstellar visitor Borisov, probability below 1%. It arrived from a direction coincident within 9 degrees of the 1977 WOW signal from Sagittarius.
On August 15th, 1977, there was a very famous flare in the radio signal that was given the name the WOW signal because the observers that recorded it at Ohio State University was stunned at how powerful this signal was. And I checked it. Turns out that it came from about the same direction in the sky as 3I Atlas.
Likelihood 0.6%. Near perihelion, it brightened faster than any recorded comet and glowed bluer than the Sun itself. Its jets require unreasonably large surface area to absorb enough sunlight for the observed mass flux. It exhibits non-gravitational acceleration, demanding at least 13% mass loss, Yet preliminary images show the object maintained structural integrity without fragmentation.
We would see an object that maintained its integrity and has very high-speed jets coming out of it, in which case we will have to contemplate a technological origin.
11 anomalies, each improbable. Together, they form a statistical profile that challenges natural formation. What separates professionals from amateurs is recognizing when measurements contradict observations, and the 12th anomaly embodies that contradiction perfectly. 7 independent telescopes measured 3 I-Atlas's rotation rate between July and August 2025, producing a highly precise period, 16.16 hours. The measurements were repeated multiple times across weeks. Identical results, no variance. This isn't uncertain data or preliminary estimates. It's confirmed observational fact from coordinated facilities. Earlier imagery from November 9th had revealed enormous gas jets extending millions of kilometers into space. Using the measured speed of this outflowing material, Loeb calculated the travel time required for gas to move from the object's surface to the visible jet terminations, roughly 1 month. Standard ballistic motion, straightforward physics. The next 30 seconds reveal a contradiction that's stumping Harvard astrophysicists. Here's where the inconsistency emerges. Over a 1-month travel span, an object with a 16.16-hour rotation period completes approximately 45 full rotations, about 1.5 spins per day. According to fundamental principles governing rotating bodies, material ejected from a spinning source should spread out as the object continues turning. The gas particles move outward in straight lines, while the nucleus keeps rotating beneath them, exposing new venting regions to sunlight, creating trails that extend in multiple directions or form spiral structures. This is textbook behavior observed in every rotating comet we've studied. Picture a lighthouse beam sweeping across the ocean. The light itself travels straight, but because the source rotates, the illuminated path traces an arc. That's what comets do. Gas vents activate as they rotate into sunlight, and jets bloom and curve like brush strokes painted by the nucleus's spin. 3 I-Atlas's jets behave differently. They appear as sharp, narrow beams, maintaining single, consistent directions across nearly 1 million kilometers. No spreading, no spiraling, no curvature, despite the source spinning 45 times during the gas's journey. The jets look frozen, as if emerging from a stationary object. Pay attention to what happens when all 3 natural explanations fail. Loeb proposed 3 theories. First, rotation slowed since July, reducing smearing, but asymmetric outgassing increases spin rate through torque, not decreases it. November 11th images show the nucleus intact. No catastrophic event to alter rotation. Theory 1 fails. Second, deep valleys with shaded ice, sunlight aligning once per rotation to pulse the jets every 16 hours. Problem: month-long travel time would create spaced segments like beads on a string, not smooth, continuous jets. Observations show no gaps. Theory 2 fails. Third, fragmentation. Jets are debris trails. Data confirms 3 I-Atlas hasn't broken apart. Theory 3 fails. This is where standard comet physics stops working entirely. Before we continue, ask yourself what natural process achieves this precision. To maintain straightness across 1 million kilometers while rotating dozens of times requires compensating for every spin with perfect accuracy. No known geological or thermal mechanism can do this. Hold on. The 4th explanation is the one scientists approach carefully. Spacecraft use reaction control thrusters, orientation independent of spin, automatic compensation, maintaining trajectory despite rotation. 3. I-Atlas's jets resemble this. Loeb presents it cautiously, noting the behavior mirrors what engineered attitude control would produce. Yet even without invoking technology, if the explanation is natural, it involves processes never observed in any known comet. Interior structures with rotational decoupling, exotic materials, ice formations maintaining consistent emission regardless of spin. Nature tends toward chaos, not precision. Rotating comets are messy, jets that flicker, bend, twist. The laser-like straightness suggests order, a coordinated response to rotation. A global network of observatories is reprocessing imaging, cross-correlating brightness variations with rotation, searching for answers with data, not speculation. Radio telescopes listen for structured emissions. Spectroscopy analyzes jet chemistry. Velocity measurements refine travel time calculations. Early indications suggest typical comet speeds, meaning the month-long timeline remains robust. The contradiction persists. Long-lived jets from a spinning object, showing no evidence of the spin that created them. 3. Atlas's 12 anomalies form a narrative of defiance. Each refuses to conform. The 12th is most profound, confronting the principles governing angular momentum and mass ejection. When evidence refuses to fit the model, what changes? The cosmos answers, slowly. 3. Atlas has offered a clue, a straight, unwavering line drawn across a spinning world, inviting humanity to follow it into deeper mysteries still unfolding. Physics has rules, tested across centuries. But every rule has boundaries. It applies where it was tested. 3. Atlas may be showing us the edge of that domain, where familiar rules begin to bend, or where new rules govern behaviors we're only now witnessing. Either way, the straight jets remain, patient and inexplicable, waiting for us to catch up.